River boat examples. A river is having a steady flow and a person or boatman across the river is standing on the bank, wants to cross the river. W is the width of river. Means this is W, point A, this is B point. Boatman has the velocity with respect to river VBR. Velocity of boatman with respect to river. He maintains the angle theta, that of his velocity, with the line, this AB. What is this line? This is the line perpendicular to river flow, or you might say it is the line across the river that gives you the width of the river. This angle is theta. You resolve this into two components, you'll find here VBR cos theta, and this side it will be VBR sin theta. River is having the flow from left to right here in the figure. So this is the velocity of river flow. We'll consider this y-axis and this one as x-axis. Now we want to find velocity of the boatman along y-axis. Velocity of the boatman along y-axis. This is going to be y component of this. It becomes VBR cos theta, and y component of VR, when you want to find the component of a vector at its right angle, it becomes 0. So VR y component shall be equal to 0. Similarly, you want to find x component of velocity of boatman. You have to consider both x component of this VBR and x component of velocity of river. But since this is already along the x-axis, you just combine the two, but you find they are in opposite direction. It becomes VR minus VBR sin theta. You want to find what is the time. Here one thing I would tell you first, that you want to find VB, then square of this shall be VBY square plus VB x square. Means by squaring the values of 2 and adding together, you'll find the square of mean or resultant velocity. If now you want to find, I'm sorry, we have to rub this. If you want to find the time taken in crossing the river, consider y-axis. Y-axis. Here, the distance to be covered along y-axis shall be W, the width of the river. And the velocity along this axis, that's y-axis, is only VBR cos theta. This is the time taken in crossing the river. You want to find minimum time. You make an aim that you want to cross the river in shortest time. So these two things are not variable, that is beyond your control. What you can do is only you can have a check on theta. By varying theta, you can have various values of cos theta. You want t minimum, this should be maximum. Cos theta is maximum equal to +1, and this will be equal to +1 only when theta is 0. In that case, you get minimum time, that is W equal to W upon VBR. This is minimum time taken in crossing the river. But then you must remember this result. What is this result? You have to take theta 0. What to say? Theta 0 means simply along AB. And what is AB? Just across the river, perpendicular to river. Now we can conclude that in order to cross the river in shortest time, one has to start perpendicular to river flow. Second thing, the boatman started at angle theta here, but the river is continuously flowing. So what river will do, it will turn the boat gradually along the flow of the river, and while reaching the end or the other side of the river, the boat will be shifted a little along this. This is known as shifting a boat, or sometimes it's also referred to as drift of the boat. This is the drifting. X, this will be velocity into time. Velocity, because you are considering x-axis, velocity will be taken along x-axis. This one. This is VBX. This is VR minus VBR sine theta, the velocity along x-axis. And time, you should remember, time was W upon VBR cos theta. This is time we are using in place of time, and velocity will be chosen this one. This is VR minus VBR sine theta. This is shift that was produced because of the river flow. Otherwise, boatman started in this direction, he should have reached over here, but the river made the boat shifted along the flow. This value you can calculate. Here also we are going to impose one condition. We have an idea to have minimum shift. What could be changed here from this point of view, that you are aiming at minimum shift, not changeable? This is possible. If you make it 0, this is minus, this is difference. Difference could easily be made 0. If you make this whole term within bracket 0, x would be minimum. So condition for minimum, x becomes VR minus VBR sine theta. This is 0. This becomes the condition for x minimum. X minimum in this case would be equal to 0. When this is 0, obviously x will be 0. This is minimum shifting. And minimum shifting means x has become 0. Where will the boatman reach? Boatman will reach point B only. That is, the path will be, in that case, shortest. If x is minimum and the boatman reaches exactly opposite to starting point, this path is going to be shortest path. Condition is this. And for sine theta, you know the condition that sine theta can never be greater than 1. This is impossible. Sine theta always lies between -1 and +1. So if this is impossible, then sine theta equal to VR upon VBR. This is also impossible. What does it mean? It means if river velocity exceeds the velocity of boat, means boat is having the velocity less than the river flow, in that case this condition can never be imagined. Shortest path is impossible. One more thing. Sine theta could have the value 1. And this is possible when theta equal to 90 degree. Let's check the validity of this condition, whether it will be feasible. If you take theta 90, see here, you take theta 90. That means, see, this is W, this is the bank of the river, this angle is theta. You take theta 90 means you start this way. If you are going this way, that means you haven't entered the river even. And in that case, it is just impossible to cross the river. So this too is not feasible. This is quite impossible. If the velocity of boat is less than river flow, one can never have this condition of shortest path. And if theta is 90, one cannot cross the river even.